Hello students, welcome to the physics class. Today we are going to start a very interesting chapter and the name of the chapter is work and energy. If you know work, you can calculate power and energy is nothing but your work done. So first we will discuss about work, a very important topic of this chapter. Please concentrate it very nicely. First, what is work? A person is sitting. Suppose a body is sitting. Is it a work? No, I cannot say it's a work. The reason I will tell you. You are studying. You think that you are working hard a lot, but this is not a work in physics. A guy is doing push-up or he is trying to push the wall. Is it a work? So all these things comes in our brain whenever we study the concept of work. Let me tell you one thing very important about this chapter. Whenever we consider work, work means there has to be two things involved. Whenever we are applying force on any object, there must be displacement. The body must move. That's why we say working hard for your studies is not a work, okay, in physics, in mechanics. So what we got from here, that there must be some motion. So in our life process, we will see that lot of things are considered as work, but it is not actually as work, but there are things which we are doing where work is involved. There is also angle involved in the work. In what angle force and displacement are playing the role, whether force and displacement are parallel with each other, whether force and displacement are opposite in direction, okay, what will be the angle theta, all those things we will be studying in this chapter. A coolie, if you go to a railway station, he used to take everything on his head rather than taking it in your hand or in his hand. Why? The reason behind this, he have to do a little less work. So work done will be less. So in this chapter, we will be dealing with work at first. So these are the introduction of the chapter, my dear. I hope you will start this chapter with lot of enthusiasm. So let us start with work. In this part, we will be dealing with work and its definition also. First, I want to quote one thing. Not much work in spite of working hard. As I told you, if you are studying and if you are sitting, there is no work done out here. Fine. So please clear this concept in your brain that whenever you're doing or you're giving work from your brain, this is not work in physics. In physics, work means there must be some displacement and force. As for example, a boy is pushing the box, as you can see on the screen. This is work. A person is climbing in a staircase. This is also work. So this can be notated scientifically. So scientific notations of work can be cited few example. Again, a boy is pushing the box. This is where I can say that work done is equal to force multiplied with displacement. We'll talk about it, don't worry. A pebble is thrown into the water. What happens? While you threw the pebble, you were applying force. Then only the pebble got displaced and went into the water. And in the water itself, again, it created ripples, right? So it created displacement in the wave of the water because of that pebble. Okay. The next one is the car is moving in a highway. In order to run the car in a highway, you need fuel, right? So fuel provides you, or the gas provides you enough force, then only the car can displace. So there is always a work done by the car also. So this is the small introduction of work, I can say. How work can be classified or distinguished from another type of work which you do at home while studying. Okay. So for your difference or for your understanding, I have given you this part. Now in this part, we are going to talk about the mathematical expression of work done, or I can say work done by a constant force. Suppose I have a block resting on the horizontal surface or in any table maybe. Now what you did, you applied some force on that block. As soon as you applied the force, the block started to move and it has displaced some displacement S. Therefore, there must be some work done. There is already work done on that block, which is given by force multiplied with the displacement. So work done is equal to, I can say, in place of force, I can write down as F multiplied with S. So this is the mathematical expression of work done. Now in your higher classes you will study that there is an angle involved, which I spoke in the first part. So that angle, at what angle the force is applied, that is dependent on that. Okay, there will be an angle between the displacement and the force. Anyways, forget about all this thing, but just know that work done is equal to force multiplied with displacement. You can easily calculate the unit, or you can find the unit out of it. What will be the unit of work done? The unit of force is Newton and the unit of displacement is meter. So what it will be? It will be Newton meter. In SI, the unit will be Newton meter or Joule. So which physical quantity has got its unit as Joule? Is energy. So what is the conclusion? Work done is nothing but your energy stored in the body. Now we will be defining one thing that is known as 1 joule. Okay, 1 joule of work done when it is done. Okay, 1 joule of work done is done when a force of 1 Newton is applied on a body which displaces by an amount of 1 meter. Then only 1 joule of work will be done. The definition is given on the screen, if you can see. So 1 joule can be written as 1 Newton multiplied with 1 meter. So this is coming from work done only. So my dear students, very important formula, work is equal to force multiplied with displacement. Okay. Now there are two cases comes from this. Work can be positive as well as a negative quantity. When the direction of force and the direction of displacement is in the same direction, then only work done will be positive. Suppose I have a block in my hand and I try to give force. See, the force is in this direction and the body is also moving in this direction. That means it is in the same direction, your work done will be positive. When your work done will be negative? When the direction of force and the direction of displacement are opposite to each other. Can you think of an example? Take 3 seconds. Okay, let me tell you. Suppose you are taking something from the ground and pulling it up. You are taking it up, that means there is a displacement upward, but the force will be downward. How? Because of acceleration due to gravity. Remember in the chapter gravitation we started, or we have studied already, that the acceleration due to gravity acts towards the earth. So your force will be acting downward and the displacement will be upward. So the direction of them will be negative, hence negative work done. So in this part we have seen the meaning of work, its unit, a very important, and the definition of 1 joule, and finally we have seen what is positive work done and what is negative work done. I hope this is clear with you. My dear students, we have just completed work. Now we will be talking about energy. As we know, work is nothing but your energy. Before that, I want to ask you, which is the biggest form of energy or source of energy we can get till date? Is the sun. From sun we get enough energy, and that energy can be converted into many forms of energy. Like from sun we can get heat, from sun we can produce electricity also nowadays. How? There are some solar cell, and in that solar cell the sun's energy is converted into electrical energy. So energy is something which cannot be destroyed or created. It can be transformed from one form of energy to another. Like the energy of the sun, the heat energy is converted into light energy. So there are some energy which is present inside the nuclei of an atom. Okay, an atom comprising of nucleus, and in that nucleus there are some small particle called as proton and neutron. That proton and neutron can give us tremendous amount of energy. It is the strongest force in nature which binds protons and neutrons inside the nucleus. You have studied in chemistry, might be. So that energy can be converted into fission and fusion, like uranium bombarding. Your lot of nuclear operators are done with the help of nuclear fission and fusion. There are many sources of energy like this we have in our day-to-day life. Please see where is the real source of energy lies. So I can say energy is nothing but something you are doing in the form of work. Suppose, as for example, you are driving a nail. What you are doing? You are doing work actually, but what its work is converted into? Its energy. You are driving the nail, that means you are applying force, and nail got some displacement. So there is work done. So I can define right now what is energy. Energy is nothing but the capacity of doing work, right? The unit of energy is joule, and 1 kilojoule is equal to 1000 joule. Fine. So what are the mechanical energy? See, mechanical energy comprises of kinetic energy and potential energy. It is the addition of kinetic energy and potential energy in a body, right? So let me give you a very small example of kinetic energy. Whenever the body is in motion, any body is in motion, it will have kinetic energy in its body. Like me, if you look at me, am I moving? I am not moving. That means I don't have kinetic energy, but my hands has got kinetic energy. My hand is moving, right or not? Anything in the world which is in motion will have kinetic energy in its body. I hope it is clear with you. And any object which is not in motion, suppose the body of me, I am not in motion, the energy possessed by virtue of its shape and configuration, it will have potential energy. So I have right now enough potential energy, and if I go little up, I will have more potential energy at some particular height. So there are different forms of energy. It's not only kinetic energy and potential energy, that is the total mechanical energy, but this has got a different form, like heat energy. Heat energy is produced because of thermal energy. Like chemical energy, chemical energy is produced because of chemical bonding. And then we have light energy. Light energy is produced because of light. As I told you, sun is the biggest example of light energy. And then electric energy or electricity. Electricity is also an energy because electricity can give us many forms of energy. See, you switch on your light or in the socket, what happens? You get enough light around, right? So your electricity is giving light energy also. Sometimes with the help of electricity you can run a motor, right? Like in generator, you'll see many things is related with electricity. Fine. Now also this energy is called as electrical energy. So there are forms of energy where mechanical energy are involved. Kinetic energy and potential energy are there in every type of energy, in every form of energy. So if you want to say, or if anybody asks you what is the total energy in any particular body, you will say that it has got mechanical energy, that is kinetic, plus potential energy. A body moving faster will have more energy than the body which is moving slower, because the force and the velocity will be more. If the force is more, velocity will be more, because force is equal to mass multiplied with acceleration, and acceleration is velocity by time, right? So force is directly proportional to velocity. So more will be the velocity in a body, more will be the work done. Example, a bullet is fired and a rotating wheel. The bullet fired one will have more energy than the rotating wheel. Both of them has got energy, but the fired bullet one will have more energy, right? So any body is in motion, what I said, it's nothing but your kinetic energy. Please note that, anything in the world, because if you are discussing kinetic energy, there must be velocity involved. Otherwise the body will not possess any kinetic energy. It might have potential energy. If you keep an object above some height, it will have potential energy. Now let us first discuss broadly about kinetic energy and see its expression. The expression of kinetic energy is given by half mv square. Now we will derive that. Now we will see the expression, right, as I told you. So kinetic energy of a moving body is nothing, is your work done. Kinetic energy, it's energy, right? So it is nothing, your work done. As I told you, kinetic means you need to move. Now there is an equation of motion. We know that v square minus u square is equal to 2as, where v is your velocity, u is your velocity, but v is final velocity and u is initial velocity. 2as, where a is your acceleration, s is the displacement. From there, if I calculate s, it will be v square minus u square divided by twice a. If you bring them to the other side, you will get it like that. Now let us do it. We know work done is equal to force multiplied with displacement. Force, according to Newton's second law of motion, is mass multiplied with acceleration. So as we have already calculated in the beginning, which is v square minus u square divided by 2a, right? Acceleration get cancel out. Now you get half m v square if you multiply inside minus half m u square. As the initial velocity of the body is 0, your final expression will be half mv square. Why I have taken initial velocity to be 0? Suppose I have this object in my hand, that is my mobile phone. I want to make it move, right? So if I take it move like this, initially it was at rest and then it has got some velocity. So your initial velocity u will be equals to 0. That is why I have taken u to be 0. So kinetic energy expression, please keep that in mind, half mv square, it will help you. Now we will see one example or one numerical. Okay. So let us see in that way that if an object or I have an object of mass 15 kg is moving with a velocity of 4 meter per second, and we need to find out the kinetic energy possessed by the body, right. So very simple, you will use the formula. First, the mass of the object is 15 kg shown on the screen, the velocity of the object is 4 meter per second shown on the screen. Therefore, if you want to find out the kinetic energy, it will be half mv square. So half multiplied with m is 15 multiplied with v square. So there will be two velocities, 4 meter per second multiplied with 4 meter per second. Hence your answer will come out to be 120 joule. If you do the calculation, you will see it is 120 joule. Now my dear students, how much energy that body will have or the object will have if it is moving with uniform velocity of 4 meter per second? 120 joule. Isn't it easy? Yes, you need to practice it, okay, 1 or 2 times, then you will see that all the numericals can be easily done with the same formula. Now, as we have discussed kinetic energy, now let us go to potential energy. Fine. Now, if I have a spring which is stretched, as you can see on the screen, which is stretched and then released, then what will happen? The string will come back to its original position or the spring will come back to its original position, right or not? So whenever you are stretching something and keep it in that position, that body will have enough potential energy in its body because of its shape, size and configuration. Remember, once I release, it will have enough kinetic energy. Now, if you have seen a band bow, archery, so whenever they want to throw the arrow very far, they used to bend it very hard, very back. More you take it back, more potential energy it will possess because of its configuration. And then if you release, it will have enough kinetic energy and it will move very far. So more is the potential energy, more will be the kinetic energy after being converted. Okay. Now potential energy is an energy which possessed by the body by virtue of its shape and configuration. Please remember that. Whenever the body is in motion, I cannot say it will have potential energy, but when the bow which was taken back, that time at that particular point, it will have potential energy. It just want to get converted into kinetic energy. So what you do? You release it and the bow go very fast, right? Now let us find out the expression of potential energy. How will you find out? Now suppose I have an object which is resting on the ground as shown on the screen. I take that object little above at a height h, right? So what I have done? I have done some work on it. As I told you, energy is nothing but the capacity of doing work. So your work done will be given as force multiplied with displacement. Now what is your force? Force is mass into acceleration, but out here the force will be directed downward, yes or no? Acceleration due to gravity. So in place of A, I will write down G and the displacement, the height. What you have taken? You have taken it to some height h. So h will be its displacement. So your final work done is coming out to be mgh, and mgh is nothing, my dear. Mgh is your energy. What energy? Potential energy. You took it up some distance or some height. As soon as you release, it will convert itself into kinetic energy, right? So this is how you can calculate kinetic energy and potential energy as well. So the expression of kinetic energy is half mv square and the expression of potential energy is mgh. So with the help of this two, there is a very important thing we need to study from this chapter, and this is called as law of conservation of energy. this law is not going to end in class 9 only. If you are taking physics, if you have interest in physics in your higher classes, if you want to do engineering, this topic will be there everywhere. So you need to understand this topic very nicely. Law of conservation of energy says that the total mechanical energy in a body remains constant throughout. Like me, I have the energy, kinetic energy and potential energy. Whenever I move, wherever I go, my energy will remain constant. The energy will not change. Okay. But also I cannot get any extra amount of energy, or I cannot create any energy by myself. Okay. So energy can neither be created nor be destroyed, but I can definitely transfer my energy from one body to another body. So you have to see one example and understand that if the total mechanical energy is remaining constant, how it is possible. Okay, let me do one example. Suppose I have taken an object at some height h. Okay, remember we are going to prove the law of conservation of energy, that every point the energy remains same. The total energy is constant. So at this height, if I am keeping the object, what will be the kinetic energy? The kinetic energy will be 0 because the body is not in motion, right? What will be the potential energy? mgh, as we have already seen. So kinetic energy plus potential energy, you are getting it to be mgh. Now if I drop that thing from that some height and it comes to ground, while it came to ground, it will have what kind of energy? Kinetic energy. And what will be its potential energy? Since there are no height involved, it will be 0. Now kinetic energy will also be mgh. How? From the equation v square minus u square equals to 2as, if you put u to be 0, that is initial velocity, then v square will be equals to 2as. Okay, the derivation I am just saying you can do it by yourself. So if you put half mv square and 2as or 2gh, in place of 2as it will be 2gh. So if you cancel it out, your answer will be 2 to get cancel out, your answer will be mgh. So at that point on the ground level also, kinetic energy plus potential energy will be equal to mgh. So at above height h, mgh, on the ground also mgh. So the energy is remaining same, it is remaining constant. What I can say? Law of conservation of energy is valid out here. So in this part we have discussed about kinetic energy, we have discussed about potential energy, we have seen the derivation of kinetic energy, we have seen the derivation of potential energy. You need to practice the derivations, it is going to help you, and kindly see the numericals also. Now in this part we are going to discuss a topic known as power, which is your last topic, and we will see what is the meaning of kilowatt hour. Power is the rate of doing work. At how much time, how much work is done, like that. In 5 seconds you can do 5 joule of work. In 10 seconds you can do suppose another 5 joule of work. That will calculate your power. At how much time, how much work you can do. So power is equal to W by T. So its unit will be, work done unit is joule and unit of time is second. Joule per second. This joule per second in together in SI we call this one as watt, right? And 1000 watt will be equals to 1 kilowatt, okay? Or sometimes we can say 1000 joule per second will be equals to 1 kilowatt. 1 horsepower is equal to 746 watt. Now we are going to see commercial unit of energy. The joule, if you take, it will be too small for the industries, household and many high appliances. So we take kilowatt hour. So 1 kilowatt hour will be equal to 1000 watt multiplied with how many seconds does 1 hour has? That is 60 minutes multiplied with 60 seconds, 60 into 60. So your 1 kilowatt hour will be equals to 3.6 into 10 to the power 6 joule or watt second. So this is how you can calculate 1 kilowatt hour. It will be joule. This amount of energy is used in household appliances, in commercial areas, in anywhere you need huge amount of electricity. So we calculate this one at unit at your home, if you ask your parents, they will talk about the bill, it comes in units. Okay, 1 unit is equals to kilowatt hour. Please remember that, and the expression and the value is also given to you. Now you can answer. Fine. Let us do a numerical where a 60 watt power bulb is used and it is used for 6 hours in a day. Okay. Now we need to calculate its energy consumed. We need to calculate its units. Okay. 1 unit is equals to 1 kilowatt hour, remember. Okay. Now what you will do? 60 watt, you need to convert this one in kilowatt, right or not? So in order to convert it into kilowatt, it will be divided by 1000. So your answer will be 0.06 kilowatt. Now you need to calculate energy. Energy is what? Energy will be power multiplied with time, right? Because we know power is equals to work by time. Work by time means what? Energy by time. Hence energy will be equals to power multiplied with time. So power is your what? 0.06 watt multiplied with time is 6 hour, right? So if you do the calculation, just multiplication, and your answer will be there, which is there on the screen. So this is what we have from this topic, the meaning of power and its expression, and then we have finally 1 kilowatt hour. Please try to study this chapter very nicely, a very important chapter, and that's all.